Okay, so yesterday we started with the law of cosines, and we worked out the side angle side example. Okay, so today we're going to be working on what happens when you have the side 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 case. Okay, so again, basically it doesn't matter if it's a law of sines or a law of cosines problem. Still want you to fill out this chart. Okay, so they've given me, they asked me to solve the triangle, and they've given me A, B, and C, sides A, B, and C. So side A is 15, side C is 26, and side B is 33. Okay, now the first thing you got to check if you're given side, side, side is you need to check if there are any solutions. Okay, there's an old rule or old thing that you have to check. For a triangle to be a triangle, the two shorter sides have to be longer than the third side. Okay, so for instance, my longest side is 33. If I add up the other two sides, it has to be at least 34 for there to be a triangle there. Okay, so 15 and 26, that gives us 41. So this will create a triangle. Okay, so we're good there. So to solve it, okay, you notice we have all three sides. We don't have any of our angles. So when we start off with side, 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 we have to use that alternate form that I gave you guys to find one of the angles. So it'd just be solving law of cosines to get, for instance, if I want to find angle C, I use this equation. So this is that alternate form where I've solved the law of cosines for cosine C. And at this point, it's just plugging it into the calculator. Okay, so that means that side C is going to be equal to cosine -1, and you're going to plug in A, which is 15 squared plus 33 squared minus 26 squared over 2 times 15 times 33. Okay, because we're looking for an angle, we have to use the inverse cosine. And then we're going to plug all of that into the inverse cosine. We're going to let the calculator do the actual heavy lifting for us. So we're just going to plug all that into our calculator. Okay. And then you're going to get angle C, which is approximately 49.875965, etc., etc. Okay, so that's our angle C. So we round to the nearest tenth, so 49.9 degrees. Okay. Now, you have a choice at this point. You can either use law of cosines again to find one of the other angles. So if you wanted to, you could find angle A or angle B using the law of cosines, or you could switch to law of sines. Okay, but if you switch to the law of sines, the next angle you find better be angle A. Okay, just like we talked about before, if you're switching to the law of sines, you start finding the smallest side. Okay, so really, to be honest, if you were doing this to make sure that you didn't have to worry about that, you could have started by solving for angle B first, since it's the biggest side, and that would be the one that you would possibly have an obtuse angle in. Okay, but since we started from angle C, if we switch to law of sines, we should start with angle A first. So using law of sines, since I have my ratio here, 9 over 26 equals sine of A over 15. Okay. And then you solve for angle A, which is going to be equal to inverse sine. It's going to be 15 times the sine of 49.9 over 26, which is approximately 26.1769. And again, we round to the nearest tenth, so 26.2 degrees. And so this one, yeah, we're glad that we didn't start didn't go next to B, because now that I have two of my angles, I subtract those two from 180 and get angle B, which is 103.9 degrees. And again, if you had gone straight to angle B first, finding your second angle, you would have gotten the acute angle in the first quadrant, and it wouldn't have looked correct. Okay. I mean, and again, technically you could have used law of cosines to find all three angles, or to find both angles and then subtract from 180. Okay, so it's really up to you which way you do it. But you just need to make sure that you solve for all the angles. And again, check to make sure your answers make sense. Does my smallest side have my smallest angle measure? Does my biggest side have my biggest angle measure? Yep. Okay. So we're just using formulas at this point. Should be really, really simple.